if you take out your handouts from last class, we can take a look at example 3, and we can actually start determining graphs of rational functions of the form f of x equals ax plus b over cx plus d. So the first one, well, example 3 says that for each of the following functions, we need to state the x and the y intercepts, the asymptotes, and their behaviors, and then we need to sketch the function. So our first function is f at x equals 2x over x plus 1. So I'm just going to move this out of here so I have a little bit more room to write. So we have f at x is equal to 2x all over x plus 1. So if you remember, we calculate the x-intercept by setting y equal to 0. So we're going to calculate the x-intercept. So we're going to say 0 is equal to 2x over x plus 1. Now we can cross multiply and solve for x. So to cross multiply, we do 0 times x plus 1, which is just 0. So 0 equals 2x. We divide both sides by 2. So 0 is going to equal x. Then we want to calculate the y-intercept, and we calculate the y-intercept by setting x equal to 0. So we're going to do f at 0 is equal to 2 times 0 over 0 plus 1. So that's going to equal 0 over 1, which is 0. Next, we want to calculate or determine the vertical asymptote. So if you remember, to determine the vertical asymptote, we're looking at what we can't divide by here. So we can't divide by 0. So we don't want x plus 1 to equal 0. So to calculate our vertical asymptote, we're going to set x plus 1 equal to 0 and solve. We're going to bring the 1 over, and we have x equals negative 1. So we have a discontinuity at x equals negative 1, and that is our vertical asymptote. So going back to our lesson from before, in order to calculate our horizontal asymptote, we need to look at taking away the inconsequential data when our x gets really large, and so when it approaches positive or negative infinity. So again, as x approaches positive or negative infinity, then we know that f at x is going to approach 2x over x, because once again, as x gets really large, this plus 1, it becomes inconsequential to the denominator. So we can say then, as x approaches positive or negative infinity, that f at x is going to approach 2, because 2x divided by x is just 2. So therefore, our horizontal asymptote is going to be y equals 2. So now we have most of the information that we need in order to be able to graph the problem. So let's put some of this information onto our graph. So I'm just going to draw a quick sketch of the graph, making sure that I put a scale on. So my x-intercept and y-intercept are 0, my vertical asymptote is negative 1, and my horizontal asymptote is 2. So I'm just going to go up by 1s here. And similarly on my y-axis. So I have my y-axis, I have my x-axis, I'm going up by 1s and by 1s. So now I can plot some points. So first I'll plot my x-intercept at 0, which also happens to be my y-intercept. I will draw my vertical asymptote at x equals negative 1. And I will label it x equals negative 1. And then I will draw my horizontal asymptote at y equals 2. And I will label it y equals 2. All right, so next I want to figure out whether or not how my graph is going to approach my vertical asymptote and my horizontal asymptote. Because I have an intercept on this side of the function, I can assume that it is going to approach my asymptote coming in this direction, so approaching negative infinity when I come in from the right-hand side, and as I approach positive infinity in my end behavior, that I'm going to approach this asymptote here. And as we learned when we were looking at our linear reciprocal, and our linear over linear is the same, our functions are going to be diagonally across from each other, the two pieces of our function. So my other piece, I can just, in my quick sketch, draw it here and here. It should be getting closer and closer and closer to the asymptote. So actually, let me correct that a little bit so that we don't. So it's going to get closer and closer and closer, but never touch. And then I can label it. So f of x equals 2x over x plus 1. So now when I'm talking about my behaviors, then I have to talk about my behavior at the vertical asymptote. And then when I talk about my behavior at the horizontal asymptote, I'm always talking about the ends, right? So at both of these, I'm talking about where the arrows are. So let's just talk a little bit about the end behavior then. So my end behavior, I'm going to say that as x approaches positive infinity, so out here, I'm approaching, my y is approaching 2 from below. And as my x approaches negative infinity, so out here, my y approaches 2 from above. And when I talk about my asymptote behavior, I'm really talking about my vertical asymptote behavior. And so I take a look at what's happening as I approach that vertical asymptote from the left and from the right. So as x approaches negative 1 from the left, remember this little negative up here means from the left. So as I'm approaching from the left-hand side, so I'm on the left-hand side of the asymptote, my y values are going up towards positive infinity. And as I approach negative 1 from the right-hand side, so when I'm on the right-hand side of the asymptote, my y values are heading down towards negative infinity. And so that's it. I am done.